In this example, we will see how we can use a polynomial equation to model an application problem. Genevieve is going to throw a rock from the top of a trail overlooking the ocean. When she throws the rock upward from 160 feet above the ocean, the function h of t equals negative 16t squared plus 48t plus 160 models the height h of the rock above the ocean as a function of the time t. Now you'll notice when I read that last sentence, I slowly said the words as a function of. The reason why I did that is because that is a key phrase that should kind of set off like bells in our head. Ding, ding, ding. When you hear as a function of, you've basically been given your input and your output values based on the structure of the sentence. So when you see the phrase as a function of, you know that whatever quantity came before that phrase in the sentence is your output value, and whatever came after it is your input value. Because in general, we can say the output is a function of the input. So the way this problem is worded, it says the height of the rock is a function of the time. So since the height came first, the height is my output variable. And since the time came after the words as a function of, that tells me that time is my input variable. That's really important because when I start to solve parts A, B, and C, I need to know, am I looking for the input value or am I looking for the output value? Anytime you're working with a function, it's going to be one of two things. Either you're given the input value and you have to find the output value, or vice versa. You start by being given the output and then you have to work backwards to figure out what that input value is. So you need to know which one of those quantities you have and which one you are looking for. So let's, first of all, before we even start parts A, B, or C, I always like to set up an ordered pair. Now, I'm not actually putting values in my ordered pair yet. I'm just distinguishing between my x's and my y's, or my inputs and my outputs. So in general, we know that the input value is the first value of an ordered pair and the output value is the second value. So I'm going to label this in, comma, out. All right, because of the way that sentence was written, I know that my input is the t value and my output is h, or h of t. So instead of x, comma, y, I have t, comma, h, or time, comma, height. And it's also nice to know those units. So my time is measured in seconds and my height is measured in feet. So when I have an ordered pair from this function with actual numbers, I know that the first number of the ordered pair tells me the time, or the seconds, and the second number of the ordered pair tells me how high the rock is at that point in time. So it's an ordered pair that tells me when we are looking at that rock and at how high that rock is, okay? All right, so now let's start part A. Part A is telling us to find the zeros of the function, which will also tell us then when the rock will hit the ocean. So if I want to know when the rock will hit the ocean, that means the height of the rock is 0 because it's hit sea level. So the height is 0 feet above the ocean if it's hit the ocean. And notice how the problem says when. We have to find when this happens. That means we have to find a t value. So what I'm going to do for part A is I'm going to set my output equal to 0. That means I'm going to set h of t equal to 0 because when the height is 0, I can solve the equation to figure out the t value that gives me a height of 0. So I get 0 equals negative 16t squared plus 48t plus 160. Then what I want to do is I want to factor out a GCF. So you'll notice my GCF here is negative 16. Anytime your leading coefficient is negative, you want that negative sign to be part of your GCF. So since I factored out a negative 16, notice how it changes the signs of the polynomial that's left over in parentheses. So now I have negative 16 times the trinomial t squared minus 3t minus 10. Now I want to factor the trinomial inside the parentheses. So this factors to negative 16 on the outside, so I don't want to forget about my GCF. And then negative 16 is multiplied by the two binomials t minus 5 and t plus 2. Now I'm ready to use my zero product property. So since my GCF was just a constant, negative 16, I don't set that equal to 0 because it didn't contain a variable, so that's not going to give me a solution. So what I'm going to do is I'm going to set my two binomials equal to 0 because those are the ones that contained the variable. So either t minus 5 equals 0 or t plus 2 equals 0, which gives me the solutions of t equals 5 or t equals negative 2. Now I'm going to go back up to that ordered pair that I labeled in the beginning. So my t values, remember, those stand for seconds. So think about this. This is telling me something happened either at 5 seconds or negative 2 seconds. Well, the negative 2 seconds doesn't really make sense. So when we interpret our answer here, we are going to discard that negative 2. But in terms of the zeros, the function has two zeros. So the zeros of the function are negative 2 and 5. But in terms of the height of this rock, we say the rock will hit the ocean, which means the rock's height will be 0 in 5 seconds. So the zeros are negative 2 and 5, but the only one that really makes sense in this situation is the positive 5. Now, in terms of the graph, what this tells me is that I have two x-intercepts. So notice how I've created two ordered pairs. I've left the input value of the ordered pair blank, but I've put a 0 in the output value for each spot of those ordered pairs because remember what I did at the beginning of the problem. I set the output value to 0 and then I worked backwards to figure out the input value. Well, I got two input values, negative 2 and positive 5. So negative 2, 0 and 5, 0 will be the x-intercepts of this graph. Even though the negative 2 one is irrelevant in terms of the context of the situation, nothing happened at negative 2 seconds, it's still part of the graph, okay? All right, now let's go on to part B. Part B is asking me when the rock will be 160 feet above the ocean. So again, when? I'm being asked to find a time at when the rock was 160 feet. So again, I'm given the feet, which means I'm given the output value. So this time I'm going to set h of t equal to 160. And now it's my job to work backwards and figure out the t value that will produce an output value of 160. So my equation reads 160 equals negative 16t squared plus 48t plus 160. Okay? Before I factor out a GCF, I need to get my equation in standard form. So I'm going to subtract 160 from both sides. So I get 0 equals negative 16t squared plus 48t. And notice my constants of 160 cancel out. Now I'm going to factor out a GCF, but this time, since both terms also contain a t, my GCF is negative 16t, which leaves behind t minus 3. Again, notice the sign change. Well, now my GCF is very important because it contains a variable. So when I use my zero product property, I set negative 16t equal to 0 and also t minus 3 equal to 0. So I get two solutions here, t equals 0 and t equals 3. So that means the rock will be 160 feet above the ocean at two different points in time, 0 for 0 seconds and 3 for 3 seconds. Okay, so what this means is that the rock will be at a height of 160 feet at 0 seconds and again at 3 seconds. So if you can kind of imagine what's happening here, 0 seconds, that's when Genevieve was just about to throw the rock. She hasn't thrown it yet. So remember in the problem how it told us she was standing 160 feet above the ocean? She hasn't thrown it yet. So the rock started its journey at a height of 160 feet above the ocean. She threw the rock up in the air. So it went higher. Well, we know what goes up must come down. So on its way back down towards the ocean at 3 seconds, it was again at a height of 160 feet. So it went up and then it came back down. And at 3 seconds after she threw it, it returned to its initial height of 160 feet. Now, we can also get two ordered pairs out of this. When t equals 0, our ordered pair is 0, 160. And when t equals 3, our ordered pair is 3, 160. Because remember, it was time, height. All right. 0, 160 will later become important when we look at our y-intercept. All right, now let's look at part C. We're being asked to find the height of the rock at t equals 1.5 seconds. So now we are being given an input value of 1.5 seconds, and we have to find the height. So we have to find the output value. So this one's pretty straightforward. There's not going to be as much work as there was for parts A and B. Now I know my input value is 1.5, so all I have to do is find h of 1.5. I'm going to do that on the next slide because we're running out of room. Okay, so let's look on this next slide here, and what we're going to do, like we said before, is all we need to do is we need to find h of 1.5. So I'm going to set up my skeleton. That's going to be the first thing that I'm going to do. So what I'm going to have here is negative 16. I'm going to have an empty set of parentheses for my t value, and then I'm going to square it, and then I'm going to have plus 48 times another empty set of parentheses, and then plus 160. And now what I'm going to do is I'm going to go in and I'm going to fill in that 1.5 everywhere I made an empty set of parentheses. Okay, so you want to make sure you do your order of operations first. That means exponents come first. So you first want to do 1.5 squared, then you're going to multiply it by negative 16. But I'm just going to go ahead and give our final answer here. You can pause the video if you want to enter this on your calculator and make sure you arrive at the same answer I do, but you're going to get 196. Okay, so what that means is we have an ordered pair here. So let's label our input and output. I just want to make sure we all understand really how important it is to know your input and your output. So our 1.5 is our input value, and our 196 is our output value. So what that tells me is that if I were to look at this graph, the ordered pair 1.5 comma 196 would be on the graph of this function. Now remember how earlier we labeled these. The input value is seconds and the output value is feet. So now I can go ahead and answer the question for part C. So we were asked to find the height of the rock at 1.5 seconds. So we'll say at 1.5 seconds, the rock will be at a height of 196 feet above the ocean. So that's how we know what our height is going to be, because we were given an input value of 1.5 seconds and we found out that it paired with an output value of 196 feet.